Hey, what's going on YouTube? We should be live right now. What's up? How's it going, everybody? If it's your first time, welcome. My name is John. I am a former mathematics major. Then I worked in industry for 10 years. I worked in Silicon Valley at Apple, Lyft, and Google. And now I've turned into an independent creator. I've become a creator, and I am trying to build apps and build a practice stream where I am studying mathematics live on the internet. So today we're going to be switching from calculus to linear algebra, and I'm excited, dude. Some people have called me a linear algebra goblin, which I think is hilarious. So yeah, it's true. I'm a linear algebra goblin. But today I hope to reset back to chapter 1 and try to do chapter 1 in a little more depth. In particular, I have one thing in mind today that I'm excited for to showcase. But we're still on this book. We're still working Fraleigh and Beauregard. And yeah, let's just get started. So this is all me being on the path toward getting a new job, because being an independent creator is really freaking hard to make money, it turns out. I'm ready to move on and try to treat this purely like a hobby again. So I am in the process of applying to every single high school math teacher role in the nearby area where I live. And, you know, hopefully someday somebody will give me a chance, because I know I'll be an amazing teacher. If somebody just freaking gives me a chance, dude. Alright, Fraleigh and Beauregard, my book is literally falling apart, which is a shame because this book is out of print, so the moment that it really falls apart, maybe we have to go to Axler at that point, or something like that. Okay, so let me pull up chat, let me make sure everything is, that we're live. I need my iPad. Let me get my iPad. I'm not as set up to just go, you know, jump right into a problem today as I like to be, but, you know, I think the most important thing is to stick to a consistent schedule. Every day, every weekday, Monday through Friday, 9 a.m. Eastern is when I am live. That's the goal, at least. Let me get my iPad up on screen. And if it needs to be me just reintroducing myself and showing a giant image of a textbook, then that's what it has to be. But I need to get in the habit of every day freaking going live at the same time. Hey, what's up? Alistor 1500. Hi, my dear. Hello, my dear. Welcome, dude. Alright, so this is my iPad. I've got little folder widget things for all of my notes. Okay, so let's go, dude. I'm excited to be back to Fraleigh. I love this book. I think it's really good. We're going to be in chapter 1, vectors and vector spaces and things like that. If I come up here, it is not May 18th. Today is June 19th? Is that correct? Yes, June 19th, 2026. All right, heck yeah. And we're in Fraleigh, chapter 1, which is on vectors, matrices, and linear systems. Okay, so these are the sections in chapter 1. Today, I think I want to hit 1, 2, 3, 4, 5, 6. You know, I mean, it's kind of a lot, but I think that we can do it. So let's hit 1 through 6, all sections 1 through 6. Section 7 and Section 8 are technically optional sections, so I don't always go through those. And instead of working these sections today, another goal other goals. Maybe I have another goal that I write down. Can we start writing up our solutions in LaTeX? Can we start practicing Vim? So I want to add in some more digital elements, not always working on an iPad, but also working on the keyboard, taking notes and showing notes live, typesetting and relearning LaTeX. Because I don't freaking remember LaTeX at all. Relearning. If we get to it, the way that I want to do this, I found this amazing new note-taking app called Zen Notes. So let me give a little shout out to that. Okay, cool. Well, let's get started. So in chapter 1, vectors, matrices, and linear systems, we solved these types of problems like a few days ago. Draw the vector -3u plus 2w if u and w are these, for example. And then you approximate, 2w is this red vector. -3u would be the length of u 3 times in the opposite direction. And then to draw the addition of those two vectors, you form a parallelogram. So really, like, we add vectors tip to tail. And let me erase this dotted red line, because I feel if I do that idea and show that I'm adding another vector here, the vector that we're adding is actually kind of like a copy of the blue vector, right? And this is a copy of the red vector. Then the addition is this yellow vector that goes from the origin to the other corner of this parallelogram. Okay, so that's similar to a problem that we're about to work. Nowadays, I've just been freaking clipping the exercises directly from the book because this book is out of print, and I don't think anybody minds if I'm going to promote their book. Section 1, where's the exercises? Okay, cool. So how far are we in these exercises? There's a lot of great exercises in this book. I think it's an excellent book, dude. I really think Fraleigh is better than Strang for an introduction. And I think it's also better than Axler for an introduction. You will see so many people recommend those books. But I think that this one is better, dude. Okay, I'll just clip all of this. And we've already done 13, 14, and 15. So we're going to work number 16. Okay. So problem 16. How's it going, y'all? How's it going, Alistor? How is your day going, dude? Thanks for tuning in, everybody. Let me know if you can hear me, because I don't know, I've been having a lot of technical difficulties recently, so I want to make sure everything is working fine. How do I pop out the dashboard again? How do I do that? I guess it doesn't matter. Hey, nobody's hit the like button yet, dude. Nobody has hit the like button. Come on, hit the like button, bro. It helps me so much. You all don't understand. It really does. I'm not gonna move on. I see that there's 3 people watching and 0 likes. I'm gonna sit here and continue begging for likes until the viewers become 0 or the likes go up. Okay? I refuse. Not to be rude, but and we all forget. We all forget to hit the like button. I understand. I need reminders too. But here's your friendly reminder. For me, I expect it. If you like my stream and you want to, if you like my stream, I expect people to hit the like button. It's not optional. Otherwise, I want you to hit the dislike button. Like, it's simple. Like, I think that it should be like a democracy. Like, everybody should vote in a good democracy. And, yeah. You have to vote either yes or no. Do you like the stream? Or you can leave. Alright, now we got 3 people and 0 likes. Let's go, dude. Let's go. Now we got 2 people and 0 likes. I am actually going to freaking sit here until I see 1 like. It's okay. I can just practice some classical guitar or something. It's fine. It's fine. If you're watching vertically, you just have to double tap your screen. If you're watching horizontally, well, there's a visible like button, like a thumbs up button that you can press really quick. Okay. Okay. Here are our options. We can either get to 1 like or 0 viewers. Until then, I'm going to practice some classical guitar, or I'm going to work on my nails more specifically. I suppose I could at least give you all. I'll be kind. I will give you all the problem, so that you can, if anybody else wants to work this problem during this boring segment. Here's the figure. I'll give this to you. And I will show what in the hell we're doing right now. Section 1.1. Vectors in Euclidean spaces. I'm just going to write vectors in Rn. Okay. Cool. Now we got 6 viewers and 0 likes. Let's freaking go, dude. That's 6 whole people who could hit the like button so I can do more math. Until then, I'm going to practice some classical guitar. I'm literally not moving on. I'm not going to continue until I see 1 like. I mean, I guess it's true that somebody could hit the like button now for the classical guitar, but that would be okay too. Hey, what's up, El Cookie? You could be the one, dude. How's it going, bro? now I still see three viewers and 0 likes. I'm serious about this right now. We are not moving on until I see either 1 like or 0 viewers. What am I gonna do next? I gotta work on a tiny bit on my ring finger nail. I hope you all enjoyed that classical guitar piece. Oh, you're getting double music, aren't you? My bad. Yeah, you're getting double music. So I am also a classical guitarist. I run a classical guitar practice stream, and this entire stream is kind of an evolution of that. Classical guitar is just purely a hobby for me, and I just love sharing my passion and everything for this hobby. Math is somewhere in between a hobby and a professional pursuit. Hey, Zafar, how's it going, dude? Did you see that Kay is back, bro? Kay is back, dude. You can go watch him if you want. I don't know if he's live, but yeah. I hope that if he's still live whenever I'm done, then I will be for sure swinging by and saying hi. Very happy to hear. Oh, I don't know if he has streaming privileges back yet. But I saw that he has his account back and he made a post. Okay, so I'm going to practice classical guitar now. The king has returned. Yes, indeed. Saw the post. Heck yeah, man. Heck yeah. Very happy to see it. I hope that we can have him on. He and I have talked about doing a collab on my stream at some point where I'm going to try to teach him, or I'm going to practice like my solution to the irreducibility of the dihedral group representation for Dn. In the last stream of representation theory, I finally got a solution. It's a little messy, but I got a solution, I think, for D8. I just need to extend it a little bit, and then I think that I can teach K-theory why D8 is irreducible. D8 into 2x2 complex matrices given by blah 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 is irreducible. So, yeah, right now I'm on strike. I'm literally on strike, just like the screen says. I don't know if it's on my end. Let me try refreshing the page. Maybe Chrome. Hell yeah, I see 1 like. Thank you, whoever you are. Whoever you are, I appreciate you. Let's continue with the mathematics. All right, thank you. Let's continue. Okay, so this problem, we're back to linear algebra. I know we keep resetting and doing simpler math, but hey, I'm practicing teaching, I'm practicing tech skills, and we're getting into harder problems over time. So let's see. I think I can work this problem. It's not going to be too hard. 2u minus v plus a half of w. Okay, so let's see what this would be. If u is in yellow, then just kind of feeling muscle memory, or just feeling the length, just kind of like almost a time, like it takes this long and then do it again. I draw u in the opposite direction. So here's negative u, but we want to do that again. So something like around here is negative 2u. Oh wait, why am I saying negative 2u? It's positive 2u. My bad. Okay, so 2u, 1, 2, is going to be about here. Probably a little bit further, but whatever. Minus v. So v is this little short guy, and minus v would be in the opposite direction. Oh, wait a minute. Dude, can I do something crazy? Does this work? Wait a minute. Mirror horizontally or mirror vertically? That's not going to exactly be the right. Oh, and it's going to mirror everything. Okay, that didn't work. I was wondering if I could mirror around a point or something. Nah, that's too fancy. That's too niche. Okay, so here's negative v. Heck yeah. And now plus 1/2 of w. 1/2 of w, then let's draw it right here. This is 1/2 of w. Right? Now, I can draw the... I suppose I could just duplicate. Oops, that didn't work. Here, can I do... okay. Well, I drew the... I drew this a little too close to the rest of the clipped problem. Otherwise, I could do some pretty cool little magic tricks. Anyways, oh well. Something like this is adding 2u to negative v, or adding negative v to 2u. Either way, we get to this point. And maybe I do it in, I don't even know, green? So this is 2u minus v. Then we need to add 1/2 of w. So that's going to be like just about right over, boop, boop. So this is, the red dotted line looks like the red solid arrow on the left, but just a mirrored copy of it. And if I wanted to draw the green one, we also get the same thing. And now here is our solution. Which is 2u minus v plus 1/2 of w. I decided on your REU project. I tried fiddling around with it, but got nowhere. Apparently research is hard. Yeah, research is hard. That is true. Yeah, I did some undergraduate research, and I found it very hard. Yeah. What is your topic that you're interested in? And what do you mean you decided on your REU project and you've already gotten nowhere? Like, when did you decide on your project? Do you mean in one day you've gotten nowhere? It takes more than one day, bro. It takes more than one day for sure to make progress, I think. Top of the morning to you. Top of the morning to you, my friend. How's it going, Arad? All right, so now we're back to linear algebra again. Spiral learning, yada, 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 you all know. Okay, so we just did that problem. Let's move on. But I got a couple of extra goals for today that are new. I want you all to help me, first off, get through 6 sections, the 6 important required sections in this thing. And today, I want to try to start relearning LaTeX. And I want to typeset at least one solution today. So I'm hoping to typeset something today. using Vim in a new app called ZenNotes. Okay, and I was protesting at one point, but now we can erase this. Let's just keep it. Why not? All right. Now, section 1.2. Oops. White. Section 1.2 is the norm and the dot product. Yo, what's up, El Cookie? How are you, bro? How's it going? Thank you all for the likes. It really, really, really helps. I went on strike a little bit earlier, so I apologize that took a while, but, yeah, I hope it comes across the right way when I say that I expect it. Like, it's not just like a suggestion. If you're a regular or if you like the stream, I expect you all to hit the like button because it's completely free and it only takes 2 seconds. So it's kind of like a democracy. If you like the stream, you have to hit the like button. If you dislike the stream, please hit the dislike button. But it's kind of your responsibility as a citizen of YouTube to vote on every video, I think. So, thank you. It really, really, really helps the channel. It really helps the channel grow. Hard to overemphasize that. 2, 1, -1, and W is -2, -1, 3. Find the indicated quality, a non-zero vector perpendicular to both U and W. Cool. We all need reminders, though, periodically. So I will just say it periodically because I forget. We all forget about it, and no worries. Yeah, the deadline for deciding a project was today. My project is stuff to do with random plane graphs. Ooh, that sounds cool, man. Hey, enjoy dinner. What's for dinner, Zafar? What's for dinner, bro? And I'm doing really good, El Cookie. Thank you for asking. I just found out yesterday about a new private school teaching position, and I'm just crossing my fingers that I might get an interview for it. Because, dude, I have nothing against public school. I'd be happy to teach public school. But if I could I think I'm ready to go today. I could teach today in the right classroom, guided by the right mentor. And like, I'd rather just get started today. Private schools don't require the same level of licensure, and I don't have to formally take a year-long training, So, fingers crossed, y'all. Okay, so recall 2 vectors, A dot B, two vectors A and B are orthogonal if A dot B equals 0. So let T, I guess, let T be orthogonal to U and W. So t dot -1, 3, 4 equals 0, and t dot u and w, -2, -1, 3 equals 0. Therefore, -t1 plus 3t2 plus 4t3 equals 0, and -2t1 minus t2 plus 3t3 equals 0. Label these equations 1 and 2. From equation 1, t1 equals 3t2 plus 4t3. So substituting into equation 2, -2 times t1 minus t2 plus 3t3 equals 0. Therefore, we want to solve, let's see, collect all the t2 terms. -6 minus 1, -7t1, collect all the t3 terms, -8 plus 3, -8 plus 3, this first one was t2. So now, anytime that we have 7t2 equal -5t3, or t2 equals -5/7 t3. Let maybe t3 be 1, then t2 is, or better yet, let t3 be 7, then t2 is -5, and coming back to our previous equation, and because then t1 is 3 times t2 plus 4 times t3, which is -15 plus 28. 28 minus 15 is 13. So a vector, or I could say even better yet, so t equal to 13, 13, -5, 7 is orthogonal to both u, which was negative 134, and W, which is negative 2, negative 1, 3. We can check our work. We can double check that we didn't make any mistakes. T dot U is negative 13 minus 15 plus 28. And this is negative 28 plus 28, and that is indeed 0. And now T dot W is negative 26 plus 5 plus 21. 5 plus 21 is 26, so this is 0. Heck yeah. So we confirmed that this solution worked. And of course, I could have solved this using matrices and other tools that we learn later on, but my goal right now is not to solve this problem. My goal is to learn the material as if I didn't know about matrices. This is section 2 before the book introduces matrices. So I'm thinking about how Fraleigh is giving a sneak peek to future problems that are all about this idea. So we could go even further and note that we made an assumption right here. So that's one free variable, and you could write down all solutions, leaving that as a variable. But this is a cool problem because you can figure this out if you think about it just from the definitions that we've learned so far, just from the fact that this means A is orthogonal to B, right? So that's a pretty cool problem. I like that he gives a sneak peek to future exercises. What's up? Let me read. Did chemistry all day today. Let's go. Now we'll be starting to do some maths soon. Let's go, dude. I'm thinking to start balanced study for a day, not just pure math, physics, or others. Yeah, you have to make sure that you balance your work. You're not just studying math like I am. You're trying to balance with other subjects as well, right? Hey, what's up, Vob Edits? How's it going, bro? Good to see you. Dude, do you want to help me edit videos? What do you mean by Vob Edits? Are you editing other people's stuff or your own edits? Like, what does your name mean, by the way? Yeah, dude, I've definitely tried ring theory. Beautiful stuff. Ooh, Arad, that sounds really cool. Please do bring up topics like the fact that you're studying algebraic geometry. Please do bring up and chat about that kind of stuff. I think that's awesome. Like, you all can ignore me completely and have your own side conversation about math as much as you want. Like, I think that that's awesome. I think that's actually a good use of this, little community. You're talking about levels of infinity once. Do they come under real analysis branch of math? Yes and no. I mean, yes. I learned it first in real analysis, but it kind of it becomes a subject of math that's more foundational. It becomes more foundational in set theory. It's kind of like a set theory branch of math. But math is not cleanly separated into these different branches the way that we like to pretend. But it definitely, the different sizes of infinity, like cardinal and ordinal numbers, is a branch of math really that comes from logic and set theory. it's like more foundational than real analysis. But it was motivated by real analysis and determining the size of the real numbers compared to the size of the integers. So yeah, hey, what's up, Jadugar? How are you? What's up, everybody? You did limits whole day. Now we'll study more limits. Let's go. The editing stuff is my brother's doings. Okay. You're just a math obsessed person. Me too. Me too. Yeah, I have studied ring theory a bunch, man. I have definitely studied ring theory. It's beautiful. Have you studied group theory? I like group theory a little bit more myself. Have you studied any group theory yet? Because rings are groups. Rings are groups with more structure. Like, groups are simpler than rings. So if you haven't studied groups, you should also be studying groups at the same time if you're learning ring theory. All right. Cool. I'm going to take a quick break. I got to go hit the loo, hit the little boys' room. I will be right back. I hope you all enjoyed. Oh, you're doing group theory nowadays. Heck yeah, I knew it. You should be doing both. If you've studied some ring theory, you should be studying some group theory too. Okay. So let's leave it. I like this. No, I don't. Here we go. All right, be right back. Hey, I'm back. What's up, y'all? How's it going? So, now we are going to be talking about matrices and their algebra. Let's get the background music back. There we go. Background music should be back. El Kuki, you enjoyed which song? Was it the first one that you were talking about or the second? Dude, thank you. I hope you enjoyed it. If anybody doesn't know, I have a classical guitar channel. And this channel is actually my second. I think it's gonna overtake the guitar channel, kind of rapidly. I feel like if it keeps growing at the level that it has been, it's going to pass the guitar stream in just a few months or something, which is amazing. I mean, that would be incredible. My concept for channels, for streams, is that it's just boring as hell. It's literally super boring. It's me working, and some of you all enjoy it. Not many people, but some people enjoy watching me actually getting work done. That's the concept here. That's the idea. It's not as popular. It's much more niche than other channels, other streams. I don't care if I don't have 100,000 subscribers, right? Whether it's your math or your music, it's so chill and relaxing. Hell yeah, dude. That's the goal. That's the idea, bro. I think that it's kind of like co-working streams, like Pomodoro, kind of, but I'm actively talking the whole time. But both of them are, I guess, the idea is that it's kind of, for both of them, nutritional content, right? This is nutritional content for your brain. It's oh, that's nice. It's ASMR Hawaii videos. Oh, look at that. I'm in Hawaii now. Look at how beautiful that is. This is good for your brain, even if it is stimulating. There's some dopamine, there's some Subway Surfers happening sometimes. There's a little bit of Subway Surfers while I'm practicing, but hopefully it's beautiful at the same time. Do I have one here? I do! Look at that. I have a Math Hawaii. I forgot I have a Math Hawaii. Look at that. It can be relaxing, and for some people, they might be able to study to it. Other people might want to just hang out, chill, chat, meet other like-minded nerds. Right? You get it. Okay. Let's get chat back up. Find A transpose A, where A is -2, 1, 3, 4, 0, -1. The longer problem statement says, if possible. So this may or may not be defined. A transpose is this. How do I write this? For every element of Aij, we swap the indices. So A11 is still A11. But A12 equals A21. A21 equals A12. A22 is A22. Maybe it's better if I write this out more explicitly. So A11, A21, and there is no A31. This entry should be A12. this entry is A22. And then in A23, it would be A32, but that's not defined. So in general, if you have a matrix A, which is an n by m matrix, then A transpose is an m by n matrix. So in our example, A is a 2 by 3, so A transpose should be a 3 by 2. Okay? So we're seeing that pattern. Then A 3-1, or like A 3-1 becomes A 1-3, and finally A 3-2 becomes A 2-3. This is -2, 0. So those entries are fixed along the diagonal. And then A 2-1 is 4, A 1-2 is 1, A 1-3 is 3, and A 2-3 is -1. Okay, so I'm very used to the idea that A transpose, for every row of A, you write the rows of A as columns. So once you get used to that, you just start to write this much more quickly. -2, 1, 3, 4, 0, -1. But I wanted to define it a little more carefully here and say that this is really the definition. This is the definition of A transpose. You swap the indices of every element. Hi, do you still work in a company? No, I am self-employed right now, and I'm trying to work for a high school or a middle school, like a nearby school. Trying to become a teacher because working for yourself is very hard. Turns out to be harder than I expected. So, yeah, Aryan Singh, I don't know if you've been here before. If not, nice to meet you, dude. I got a bachelor's in math with honors. Then I worked at Apple as an iOS engineer. Then I worked at Lyft as an iOS engineer. Then I worked at Google as an iOS engineer. Now I'm self-employed. And I'm trying, to become a teacher. So that's my path. Yeah, I can give you advice about pursuing math as a hobby. I'd say just do it. Find some way to track it and do it every single day. Like, that is a general advice for anything. If you want to do something and get better at something, find your favorite way to track it. I really like just really simple dotted note cards and just cross out a square every time that you do a thing. And just your goal is to just cross out squares in a calendar or on a note card, or crossing out exercises in books, but just like track it and try to do the thing every day. Even if it's just a tiny bit. But use timers so that you make sure that you time box and you don't let your hobby take over your life. Because as you said, you want to do math as a hobby. Me too. Same here. So as much as I love studying category theory for 4 hours straight, that's more than I need to. My goal is to complete some interesting textbooks because you want to learn math for fun. Like, is the goal to have fun for you, or is the goal to stretch your brain, get smarter? Like, is it to stay active? Is it, like, ultimately, why do you want to solve interesting textbooks? Do you want to become good at math? If so, why? Why do you want to get good at math? Do you want to do research? Do you want to teach others? Do you want to get paid? Or do you want to do it for yourself, for fun or something? Both. Both is not allowed. You have to pick. You know? Like, even if it's 51% versus 49%, what is your goal? Like, really have that clear in your mind. And you started this by saying as a hobby. So I want to hear you say that you want to study math for fun. Like, is it because you want to keep your brain smart? Is it that you want to stay sharp? Or is it that you want to have fun and you enjoy it? Math can be fun. I find math fun. I find this fun. Like, you're allowed to say that you want to study math for fun. You're allowed to think that. I just like solving hard problems. The dopamine hit is so good. Hell yeah, dude. And that's good dopamine. Like, it is dopamine at the end of the day, but it's like better dopamine, dude. Like, a couple of years ago, I had like a really bad TikTok habit, dude. Like, because I was a creator, I was a guitarist, trying to promote myself on, I was trying to promote myself as a guitarist on TikTok. And so I was posting a lot and I was watching a lot of TikTok all the time to try to understand what works and what doesn't. Dude, that's the worst dopamine in the world. There's better dopamine than other dopamine out there. And like, solving math problems, great dopamine compared to TikTok. So that's an advice that I'd give a lot of people is like, find better dopamine than others. Like, keep upgrading your dopamine game until it's something that you enjoy doing and it feels good for you or something. Let's come back to the iPad. So that's a good reason. That is a valid reason. You're allowed to say that you want dopamine and that's why you want to study math. I think that's freaking awesome. But not enough people are saying that math is fun. And I want people to just say that proudly. Math is freaking fun. It is. Like, doing Sudokus for some people is fun. And they want to, you know, get that sweet, sweet dopamine by solving Sudokus. It's not that different. All right, so -2 times -2 plus 4 times 4 is 16 plus 4 is 20. -2, for those who haven't seen this before, to get, say, this entry, which is the first row, second column, you take the dot product of row 1 and the dot product with column 2 of these two matrices. Of whatever the matrices are, I'm going to take the dot product of the first row with the second column. And what is the dot product? Well, by one example, the dot product, you multiply the corresponding components. So think of this vector. So you multiply the components together. And then, from that, then you add those together. A1, B1 plus A2, B2. This is the dot product. The sum of the products of components. So negative 2 times 1 is negative 2 plus 4 times 0. So we have negative 2 plus 0 is negative 2. I have those highlighted just to get one example on screen. Negative 6 minus 4. Negative 6 minus 4 is negative 10. 1 times negative 2 plus 0 is negative 2. 1 times 1 plus 0. 1 times 3 plus 0. 3 times negative 2 minus 4 is negative 10. 3 plus 0. And 9 plus 1. Heck yeah. Here is our solution. This is A transpose A. Notice some cool patterns. These match. These match. These match. Right? Is that always true? That's a question for you to think about. Okay, we solved this one. There's number 15. How's it going? How's it going? Yeah, of course, dude. Math is one of the most creative and fun fields ever. Exactly. It's fun and it's creative. It's art. It's actually art, like logical art. It's like puzzles. Like, dude, it's so similar to like board games or puzzles like Sudoku. People obviously play board games for fun. Math is just like board games. It's just like puzzles, like logical puzzles for some people. And I'm very passionate about insisting on that because not enough people in high school learn the idea that math can be like puzzles. Section 1.4. But it's also good at training your brain. That's another reason to study math. It's very good at making you good at problem solving. So if your goal is to get good at problem solving, that's another reason to study math. Another reason is that your job might require math. But that's not everybody. Not everybody's job requires math. A lot of jobs don't require math. Most jobs require problem solving, though. Most jobs do require problem solving skills. So even if you don't find math fun, and you don't think that you're going to pursue a math career or like engineering or something or science, something that requires math, no matter who you are, I really think that problem-solving skills are valuable. And really, kind of adjacent to that is mental cognition, dude. Just like keeping away from dementia. Like, as we just work with AI, which is better than us, is more intelligent than us, we need to practice intelligence. We need to practice like keeping your mind sharp. And math is one of the good ways to practice that. Yeah. All right, so let me read chat. You like solving hard problems? Me too. Oh, I'm back. Time to read the research-related papers. Nice. Tell us about it, dude. Tell us about it. Cool. Oh, Zafarb, you have an update that Arad listened to. Zafarb, wait, are you a YouTuber? Bro, how have you not mentioned this? Everybody, please feel free to shout out your shit. Like, oh, dude, heck yeah. Self-study update, vector calculus and differential forms. In 6 days, dude, you're like a brand new math YouTuber. Hell yeah, dude. I just became your 9th subscriber. I'm within the first 10. Dude, let's go. Everybody, shout outs to Zafarb. Go follow Zafarb, y'all. Dude, that's cool. I didn't know that. Zafarb uploads videos. I'm going to say progress videos. Nice, dude. Some content creators are very competitive and they don't want people like self-promoting and stuff like that. Dude, I do not believe in that at all. Like, we win together, you know? Like, to take like a lame, like freaking, you know, a lame motto from industry, from like The Office, like win together. Like, dude, like rising tide lifts all boats, all that. Like, I'm happy to shout out any creators in the chat. So 0 videos, 100 million subs. That's funny. Okay, I will check out your videos later. I'm not a reaction streamer, so I'm not going to watch it on stream, but you know, I'll watch them later. Okay, so now we've got a system of equations. Minus 2x equals 3. 3x1 minus x2 equals 14. And x1 minus 7x2 equals negative 2. Okay, so let's try to solve this if possible. I wonder if this will become inconsistent. 1, negative 2. So in this section, it looks like we have learned the matrix solutions using Gaussian the Gauss method with back substitution. So I'll say we use the Gauss method with back (1, negative 2, 3, 3, negative 1, 14). 1, negative 7, negative 2. So in the Gauss method with back substitution, by hand, we are going to be subtracting multiples of rows from one another. So 1, negative 2, I'm going to keep this first row fixed. And then I'll give one example here that row 2 prime, I'm going to subtract 3 times row 1. Because then that way we'll zero out this entry here. So 3 minus 3, negative 1 plus 6, and then 14 minus 9, right? And then maybe row 3 prime. If I want to zero out this entry, if I want to zero out that bottom left entry, I need to subtract the first row. So 1 minus 1 is 0. Negative 7 minus negative 2 is negative 5. Okay, so row 3 prime is row 3 minus row 1. And then in this last one, -2 minus 3 is -5. Now, if I add the second row to the third, we get this consistent system. I can divide the second row by 5, and then I can add 2 times that, 2 times the second row to the first. So 3 plus 2 is 5. Therefore, a solution is 5, 1. This is a solution to this system of equations, and it is a consistent solution. Cosmic, do you have any advice on learning maths more efficiently, at least, or faster, for calculus at least? Well, I talk about calculus and how to study calculus a lot in my calculus streams. Have you seen any of my calculus streams, dude? So let me give you a moment here. Cosmic for G5R asks, G5R, how to study calculus I'm just going to say more efficiently. I'm going to say that I really like generally speaking, I really like the idea of deliberate practice. So look into these words, and go try to understand what deliberate practice means. I believe that you might want to look into the word spaced repetition, the phrase spaced repetition. And for me, that means things like starting with section 1.1, working problems, then do another problem from 1.1, but then also do a problem from 1.2, and then repeat. Again, do another problem from the first section, then do a problem from the second section, then do a problem from the third section, right? You see the pattern. You keep doing this process and you just keep resetting, right? 1.n, or I could even say, go to chapter N, section M. But keep coming back and working the basics again, and keep coming back and work all the problems. Even if they're not assigned to you, even if it's not part of your homework sets, and they become very easy. Like for me, this is a very easy freaking exercise. If I wasn't teaching it at the same time, it would be very quick for me to do it. But then I can cross it out in my book and be like, okay, I did it. Now let's move on. Next time I'm going to get a harder problem next time that I come back to this section. The way that I'm working on this stream is this exact same idea. It's just that I did linear algebra chapter 1, then I did linear algebra chapter 1 and 2, then I did 1, 2, then I did 1, then 2, then 3, then 1, then 2, then 3, then 4, all the way until I started getting all the way to chapter 10. Then I added calculus. And representation theory. right? Do you see the pattern? So I believe in this idea, and I am living it. I'm actually doing this process. And right now, this is the cycle that we're on. In fact, right now, this is the stream that we're in at the moment. What's a good color to highlight this with? I'll just say this one. This is where we are. On day 103 or something. On day 103, I'm still working chapter 1 of linear algebra. The purpose is not for me to learn this material for the first time. The intent keeps going up and keeps getting deeper. To where I'm thinking more about how to best explain and teach this material, how to best use technology in order to teach this material. And I hope that at the end of the stream, I can learn a new skill. Today I want to, I don't care if it's in Vim or not, that's just an unnecessary, by the way, I use Vim, by the way. But today I want to start typesetting my solutions to begin. So let me read chat a little bit and catch up. You want to devote 3 hours every day to math. Aryan, before you commit to... Aryan Singh. Okay. Before you commit to 3 hours every day, the priority should be every day before it is 3 hours. Get to 50 minutes daily. Then, once that's easy for you, then go to 30 minutes daily. Then go to 1 hour daily. Then get to 2 hours daily. Then get to 3 hours daily. Or whatever. Whatever your goal is. But for you, focus on the word daily before you start worrying about whether it's 3 hours or not. So even if you only hit 15 minutes in a day, you should still consider that a success. Until your baseline, it's just no problem. 15 minutes daily, no problem, I'm doing that. Then increase your goal, and your baseline should become 30 minutes. And once that's easy, then start doing 60 minutes a day. Yeah, Cosmic, you have Stuart. I don't like Stuart. Watch my calculus streams. You'll see how much better Taalman is. So over here is Stuart, and it's very computational. Over here is Spivak, and you'll see people talk about that, and this is very theoretical. Bro, Taalman. Look at Taalman's book. It's excellent. It's both computational and theoretical. It's a really good book. I really think it's the best introduction to calculus. Much better than Stuart, much better than Spivak for your first introduction to calculus, I think. So you, Cosmic, yes, you're taking the approach that a lot of people do. You said that you're working every exercise from a section before moving on. Right? You're saying that you do this. It's the most obvious way that a lot of people take. Bro, I'm telling you, I really do think that this would be called depth first search. I'm a computer scientist, I'm a programmer, I've studied computer science, and this is a depth first search. You have a tree, and you go down every single left node before you come back and do any right nodes. Or maybe even better, yeah, if the first node is a chapter, the second node is a section, then what you're doing is you're starting in chapter 1, you're starting in section 1, and then you're doing all 100 problems in section 1, right? Or 30 or 10, however many it is, and then you come back up. Then you move on. Oh, well, whoops. I mean, chapter 1 is part of a book, right? So there's multiple chapters. And then you do, in section 2, you do all the problems in section 2. Then you come back up and you go to section 3 and you do whatever it is, 5 sections or something. And then you go here, and in the 5th section, you do all these. It works. You will hit every problem this way. Right? And then now you're done with chapter 1. Then come and do chapter 2, and you do the same process. You get what I'm saying? This is called depth first search, and it works. I don't think it's as smart for learning a subject like math as breadth first search. Breadth first search, you're gonna come over here, you're in the book. I mean, it's not perfect, but maybe you come to chapter 1. No, this is right. Yeah, chapter 1, section 1. But there's more nodes here. And finally you hit a leaf node. You hit an exercise. And you complete it. Then you backtrack, and this isn't exactly perfect, but this is what I am proposing to you. Section 2, work the first problem from section 2. And then come back. Go to section 3, work the first problem from section 3, and do this until you get stuck. If you can't make progress on a problem, once you get to a problem that you just cannot make any progress on, then reset and come back. So you're stuck, right, in red. Come back and then go back to stuff that you know, that you understand. 1.1.2, 1.2.2, 1.3.2, ... and then you get stuck again at some point, and then you loop. You just keep coming back and keep coming back to material that is easy for you, and it should be fast. Like, you know, if you understand the material really well, it should be quick. It's not going to take that much time. I just think that this is a better way to get breadth at the same time that you're getting depth. You've never heard of Taalman. Yeah, Taalman is new. It's a new book. It's good. I really think it's good. I should set up like Amazon affiliate links or something. I'm not even sponsored. Like, I have no affiliation. Not sponsored. But I think it's very good. Yeah, I hated the computational aspects of introductory calculus. Me too. That's why I don't... Like, I did not learn calculus properly because I didn't even use Stewart when I learned. I was even worse. I used the Princeton Review, bro. Like, I used, like, the prep book. I used the prep book just to pass the AP Calc exam. And I really wish I didn't do that, because calculus is an art form. Calculus is beautiful. There's more to calculus than computation. And I think that Taalman's writing is just really excellent, really clear, organized, and it showcases, you know, the theoretical, beautiful side of calculus, as well as the computational side. So... yeah, exactly. Arad says, if you're teaching a course, your teachers never assign every single problem. That's not how the books were designed. The books are designed so that you can come back and work the problems again later in more depth when you feel like it or something, or when you feel like you need more practice in one section or one topic. How much pre-calc do you think is enough for calculus? I don't know. I mean, that's a hard question to answer. Obviously, pre-calculus, by definition, is material that you should learn before calculus. Just by the word pre-calculus. You should learn this before calculus. But you don't need all of it. You don't need... Like, you can try to learn it alongside calculus if you have the free time. It depends on your goals. Like, it just depends so much on the student and their situation. If you are in a course that's all designed around getting to some exam, like whether it's AP Calculus or the JEE or something else, then maybe you want your pre-calculus to be really, really sharp and to have all those skills in place first before you start another course, because you have a deadline, you have exams, you have deadlines. But if you are somebody who's learning for yourself, you can learn it with calculus at the same time and kind of mix and match. And again, that's kind of like the breadth first search model. That is, like, you can learn just enough pre-calculus to do section 1 of calculus. And then you look at section 2 of calculus and you're like, oh shoot, I need to work on my fundamentals. And then you go work on the relevant stuff in pre-calculus. Like, I think that these can be approaches that are really different than the standard curriculum and the standard teaching model. at least in the US. I can't speak to what other countries, how other countries teach math, but in the US, I think that we could do better. We could really do better. And yeah, generally, all these books will have pre-calculus, the relevant pre-calc in the book. So you could check out my streams. Taalman, I'll say Taalman 0 is pre-calculus. There's a chapter 0, which is pre-calc. Taalman 1 is all about limits. And my streams have always so far just been these two chapters. Chapter 0 on pre-calculus, chapter 1 on limits. Yeah, especially with early topic textbooks like calculus and pre-calculus especially, they have like 100 problems in every section. Not even joking, 100 problems. You're not supposed to do all of them before moving on to the next section. That's overkill. That's not a smart way. That's not an efficient way. Now that we're talking about efficiency, like I'm a software engineer. That's what I do. I care about efficiency. Like we care about, doing things in a smart way. And at first you're thinking about depth first search and breadth first search to how long does it take for your computer to calculate some algorithm. But no, over time you start thinking at a higher level more about tasks. And we've got project 1 with sub-project 1, and within sub-project 1 you've got task 1, but then at the same time there's another project that another team wants you to be working on or something, and how do you efficiently balance tasks across different projects. And it's kind of similar. It's this is all about prioritization. And how do you prioritize your time? Prioritization. Time management, prioritization. It would not be efficient to do a depth first search. It would be dumb to work all 100 problems in your pre-calc book and then work all 40 chapters or 40 sections in your pre-calc book and work every single exercise before you start calculus. That's not a smart way to do it. Oh, you teach students. Let's go, dude. That's awesome. I didn't know that you teach. That's cool, dude. Professor Leonard courses are good. I don't know that. Let me try to look that up sometime. I kind of want to continue and try to get rip through some more problems here, but at Cosmic says, check out Professor Leonard. I don't know Professor Leonard. Is that a YouTuber? Taalman does not have a free PDF, but you should buy it. You should buy it if you can afford it. If you can't afford it, I guarantee, I bet you can find it. I'm not going to help you find it, but I think you can find it. You know what I mean? I used to find and get a lot of textbooks back in the day, even if I couldn't afford them. I found a way to get them. It's not that hard to find. Is it a good idea to complete one chapter? But it's not just that I think morally you should buy the book. It's that I think it's more efficient. I think it's better to work on paper if you can. If you're teaching or you're trying to build a YouTube channel and you're trying to become a little mini micro influencer in math or something, it's probably a good thing to use digital stuff, because this is super cool. I can zoom in and out. Look how much dopamine we're getting about this. And I can share my notes easily. Even if I wasn't a YouTuber, I could share my notes with my students. If I'm teaching, I think digital is better. But if I'm just studying for myself, paper is just the most efficient way. I think paper books and paper notebooks, you're going to learn the material better than digital. So yes, you can find a PDF. I think that you should buy it, not just because it's the morally right thing if you can afford it, but also because I think you're going to learn it better. You're just going to learn more efficiently. And if we're talking about efficiency and prioritization, then, I value my time a lot. Efficiency. Like, if it only costs me, it's less than $100, but like, say it was $100. It cost me $100 once, but I'm going to spend hundreds of hours working through that book over years, probably. Like, if you're really using that book well, you might be using that book for years, for hundreds of hours. Like, let's just be generous and for simplicity say that it takes you 100 hours to work through the book. That's $1 an hour. I value my time, my own time, way more than $1 an hour. Especially if it takes me 200 hours to work through the PDF, and it would only take me 100 hours to work through the paper book. That's just obviously worth it to me. Like, it's out there. You could find it. I don't have Super Chat yet. I'm not yet monetized. So if you want to help me, bro, like, oh, dude, I'd love it. If you really want to help Super Chat, you could subscribe to my guitar channel. This is actually my second channel. It's my priority, but my first channel is all classical guitar. You can Super Chat there, or Super Thanks, I guess. But that would be one way to say thanks. Like, it would just help a lot if you'd sub to my guitar channel. If you really, really insist that you want to get me some money and have it be related to math, I have a Buy Me a Coffee. This is my favorite. I think it's better than Patreon. And I'm jcpractices on Buy Me a Coffee. Thank you for asking. I mean, no pressure. I don't expect anything from anybody, but it does help, try to turn this into like a sustainable, like, it would be a dream come true if this could become a sustainable career. Like, if I was just a full-time math educator on YouTube, that would be amazing. That's not realistic. I don't expect that to happen, but that would be amazing. This can be one-time tips or recurring. If anybody wanted to really just commit to helping me out, and you can set any price you want. And one reason I really like this is there's like a gratitude wall. Like, you can leave public messages if you want. I think that's really nice. Like, I think that's a really cool feature. Literally just saying, like, thanks, dude, or something like that, goes a pretty long way. Like, it means a lot to me. But yeah, no worries. Hell yeah, you found the paperback for $20. I have studied real analysis. Yeah. So, I don't know if you were here when I was talking about this, but where is it? Here's my path. I did a bachelor's in math, in pure math, with a lot of graduate levels, plus grad level courses, graduate level courses. And then I worked at Apple, then I worked at Lyft, then I worked at Google. Now I'm self-employed, and hopefully soon I'll be a teacher. But but during a bachelor's of math, you definitely need real analysis. I took 3 semesters of real analysis. Yeah, I did 3 semesters, and I was never very good at it, but I was good enough. You know, I could have done a master's degree, but I wanted to go make some money instead. Apple pays well, Lyft pays really well, Google pays pretty well. Any advice for pure math? It takes practice. I don't know, just practice. I gotta continue. I do want to finish these. I really do want to finish these sections, so I will just say one last time. Where is it? I lost it. I don't know where it is. This idea. Advice for pure math, how to get good at logic. Just, dude, it's all about deliberate practice. Just practice. How do you get to Carnegie Hall? You practice. That's it. I could talk about that in more specific details in another stream, maybe. We got to keep going. Otherwise, I'm not going to get to my new goal for this stream. So, section 1.5 is about inverses of square matrices. Okay, what problem are we on now? We are in problem 14. Use the inverse of the matrix in exercise 7. Let's clip from this problem set. We're in section 5, page 84. Where are we? Okay, so we're going to work this exercise. The matrix in exercise 7. What is the matrix in exercise 7? It's this one. Okay, so notice that the matrix is exactly identical to the coefficients of that system. So this system of equations is of the form AX equal B, where this is A. Then if I find the inverse of this matrix, then I can multiply both sides by A inverse, and we have associativity, right? And the inverse times a matrix is the identity matrix, and the identity matrix multiplied by any vector is X. So then, we'd have X is, our solution is A inverse B. I think in exercise 7 we found the inverse, but let's just do it again really quick. To find the inverse of a matrix A, there's a special formula that works well for 2 by 2, but for 3 by 3, I think that this is just going to be our best option right now. We do the Gauss method to get to reduced row echelon form here. So let's find A inverse. I'm going to call this a goal. Our goal is to find A inverse. So I copy 214, 325, 0, negative 1, 1. 0, negative 1, 1. And I append, that's what the bar line means in this strategy. Like, this is our strategy to find A inverse. 0, 1, 0, 0, 0, 1. So, let's do one of these fun little reductions. Now, I'm going to double the second row and then subtract triple the first row. So 6 minus 6 is 0. 4 minus 3 is 1. 10 minus 12 is negative 2. 0 minus 3 is negative 3. Oops, almost made a mistake there. Negative 3. 2 minus 0, and then 0 minus 0. And then the third row already has a 0 in that pivot column. So I could copy that, that third row, but notice already we have a 1 in the second row and a negative 1 in the third row of the previous matrix. So I like to just kind of jump ahead and add the third row of the previous matrix to the second row of the new matrix. Negative 1 plus 1 is 0. 1 plus negative 2 is negative 1. 0 plus negative 3 is negative 3. 0 plus 2 is 2. And 1 plus 0 is 1. Now, here, well, I can multiply the last row by negative 1. And then add 2 times this new row to the second row. Then we have negative 2 plus 2. We have negative 3 plus 6. Negative 3 plus 6. Yeah. Negative 3 plus 6 is 3. 2 plus negative 4 is negative 2. And 0 plus negative 2 is negative 2. I can subtract that new second row from the first row. 2 minus 1 is 0. Oh, wait, no, sorry. 1 minus 1 is 0. 4 minus 0 is 4. 1 minus 3 is negative 2. 0 minus negative 2 is 2. And 0 minus negative 2 is 2. Then I'm just going to take a little breather and just take a breath for a moment. Just chill and do this in 2 steps. So it's easier to just divide the first row by 2 first, just to keep our life simple. than to subtract 4 times the third row. I mean, I could have done that, but it's just, let's take a little breather, right? 1, 0. Now I want 2 minus 2, negative 1 minus 6, 1 plus 4, 1 plus 2. And now we have our inverse. So I could check that A inverse times A is the identity matrix. But I feel fairly confident, so I just want to move on from that. Also, is this no, it's not an odd problem. Okay, let's just check one row. So I'm just looking at this matrix. The row 214 dot product, the column of A inverse. It should equal 1. As long as that one equals 1, I'm going to just move on. Negative 14, negative 11, damn it. Wait, negative 11 plus 12 is 1. So the first entry is 1 correctly, so I think probably. So I at least checked that A11 is 1, and I'm just going to call that good enough for right now. Then, as I said earlier, X is A inverse times B. A inverse I found is negative 7, 5, 3, 3, negative 2, negative 2, 3, negative 2, negative 1, and we multiply this with our solution vector of 5, 3, 8. So negative 35 plus 15 is negative 20. Negative 20 plus 24 is 4. 15 minus 6 is 9. 9 minus 16. 9 minus 16 is negative 7, right? Yeah, negative 7. I'm like blanking for a second. All right, 15 minus 6 is 9. 15 minus 6 is 9. 9 minus 8 is 1. So I think that X is, our solution is 4, negative 7, 1. We could just check one of the equations. So equation 1 was 2x1 plus x2, oops. I'm going to call this equation 1, 2x1 plus x2 plus 4x3. And we're going to check if that is 5. Well, 2 times x1 is 2 times 4. X2 is negative 7, and 4 times x3. Well, this is 8 minus 7 is 1. 1 plus 4 is 5. So, at least the first equation is correct. our solution works for the first equation, I feel pretty confident that we didn't make a typo anywhere. Okay, heck yeah, heck yeah. Yeah, pure math doesn't pay well. You don't do pure math for money. You do pure math for fun. Like, we need to say this more. Math is fun. There are mathematicians out there who chose fun instead of money. Like, if you're a mathematician, if you're a pure mathematician, you chose to pursue something really, really hard, like research and grad school, and you chose that because it sounded more fun to you than working at a tech company or at a hedge fund. If, like, pretty much every single math professor that you know, at least at college, every professional pure math researcher, oh my gosh, wait, let's come back. Every single math researcher who's like a university professor could be working at a hedge fund, or as an actuary, or as an engineer, as a software engineer, or a traditional engineer, and they would make more money that way. Nobody chooses academia and chooses pure math for the money. Like, you choose it because it's fun, because it's beautiful, because it's an art form and you're an artist. Like, I like to use the word artist with math that people don't think about, but it's true. Hey, what's up, Demotant? How are you? Pure math pays after you've been dead for decades. Yeah, maybe then. Like, you get, like, if you care about the glory, if you care about your legacy and your glory, sure, maybe that's why some people pick pure math. And it's not out of fun, but it, like, maybe for some people they care about having a lasting impact on humanity. Like, nobody's going to remember a random engineer at Google. Like, a random mid-tier freaking level 5 average engineer at Google. Nobody's ever going to remember them. But, hey, even if you were starving as a mathematician during your life, if you did some important work that is later remembered forever, like, for some people, they may care about legacy, and that's kind of beautiful in its own way. But you're pretty unlikely to find success in that meaning in your own lifetime. Like, it's unlikely that your research, that your work is going to be useful to anybody in your own lifetime. Like, it's a sad fact, and some people choose it because it's beautiful, because they love it, and because they find meaning in that somehow, right? At least Ramanujan did. That guy was a prodigy and a lover of math. Yeah, but most of us are not Ramanujan. Ramanujan was recognized as a genius within his own lifetime. Very much the exception. There's, like, Terence Tao. Yeah, he's a rock star. He's a famous mathematician. Everybody knows Terence Tao's name. Everybody knows Ramanujan's name. Everybody knew Einstein's name. Everybody knew Einstein in his own life. But those are the rock stars. You know? It's like, you know, they're like the Stephen Curry or whatever, the Michael Jordans of their lifetimes, like the superstars. Most people are not superstars. Okay. The Ludwigs of the time. All right, let's keep going. Is there one more required section, or are we Was that it? No, oh wait. Inverses, homogeneous systems, subspaces, and bases. Okay, we might not get to my tech goal today. My LaTeX goal, that is. That's okay, we could do it tomorrow. Totally fine. Alright, so section 1.6. Homogeneous systems, subspaces, and bases. What's our next exercise? Give a geometric description of all subspaces of R2. I feel like we did this one. Did we do this one already? Well, if we did, it was in another note file, and I lost it. Okay. Oh, well, let's do it. I feel like I remember this one. So part A, oops. Give a geometric description of all subspaces of the plane. Repeat for R cubed. Okay, so solution. It's not quite a proof because I don't think that I'm going to have a rigorous proof on this, but for part A, well, first off, recall a subspace. We need closure under vector addition, and we need closure under scalar multiplication. Is it correct to give shorthand like this? Like the set of all sum of vectors is a subspace of W, and multiplying any vector in W by a real number is also in W. I think that this is fine notation, right? I kind of like that, if it's okay with you all. And of course, you know, sneak peek, when you grow up, we learn that your scalars can be any field, K. Your scalars don't need to be the real numbers. They could be complex numbers, or you can work over a field of two numbers, like 0 and 1, a finite field. But don't worry about that. We're just working with real numbers now. Okay, so recall that W is a subspace if it's closed under addition and closed under scalar multiplication. So in part A, if let's see. 0 is always a subspace of any vector space. And in this point, my bad, we are not yet talking about vector spaces. We're only talking about Rn. So I should stick to that. But this argument really holds for vector spaces in general. Something like we abstract from this idea. So, the point 0, 0 multiplied by any scalar is 0, 0, which is in the 0 subspace, and of course 0, 0 plus 0, 0 is in, well, adding 0, 0 to itself is 0, 0 again. This is kind of an algebraic proof, but if I think geometrically in the plane, this first point is literally the origin. So first we have the origin. And when I am writing 0, I really should just be writing 0, 0. Like the xy point 0, 0 is the origin. Then we also have the entire plane. Well, that's certainly true. We always have all of our parent vector space. Our parent, like Euclidean space is a subspace of itself. Because adding any two vectors stays within the plane, and adding any two vectors gives you another two-dimensional vector. It's not like you move to a three-dimensional vector by adding two-dimensional vectors. Like a1, b1 plus a2, b2 is in R2 still. And then k times any vector AB is KA, KB, and this is still a two-dimensional vector. So the entire plane is also a vector space. Now there's a third, a geometric description. We would need for some vector that you can scale the vector. So like if I doubled, tripled, quadrupled, multiplied by 10, I'd keep getting longer vectors in that direction. But you can also multiply those by negative values. So this is all scalings. The fact that it's the fact that it is a non-zero vector, W, then the fact that it's a non-zero vector and that you can scale it, like it's closed under scalar multiplication, then any line so this is any line, in other words, y equals mx plus b with b being 0. It needs to cross through the origin. Because, yeah, vectors always start from the origin. Yeah. With m not equal to 0. If there was another, I mean, that makes a vector space as well. I think I can see that because if I add two vectors on that line, we get another vector on that line. And if I take any vector on that line and multiply it by a scalar, then I get another vector on that line. If there was some other vector space, then there would be another vector that's not on the line, W, let's say. But then, I mean, this is a concept from the next chapter, but if there was another vector, the span, you could find any point in R2 by adding a combination of U and V, of V and W. If I wanted to try to prove that, we could try to say, let AB be in R2. V and W also are in R2 with W not equal to K times vector V. Right? We'd claim that any vector in R2 is equal to K1 times V plus K2 times W. For some non-zero K1 and K2. And you'd try to write the fact that V1, V2 is equal to some K times W1, K times W2 plus a remainder. There must be some remainder that's not 0 because V1, V2 is not K times W1, W2. And then you can do a little bit of algebra to find any point AB being a combination of V1, V2, and this other one. So, I don't know. I think that would be the approach to try to express any non-zero point as a vector or a combination of V and W. I don't think that this exercise wanted us to go that far and try to prove this, In fact, I think that this section kind of already tells you these ideas, and you just need to cite the right portion of the section. But I wanted to kind of give a sneak peek to the future where we try to prove statements like that. In R3, we have the origin. We have the set of lines. Any line creates a vector space in R3. There's kind of a type error in this. A line is a subspace in R3. A plane is also a subspace of three-dimensional space. And finally, we always get a space is a subspace of itself. These are the four geometric shapes. I mean, there's infinitely many lines, there's infinitely many planes, but there's four kind of unique up to something called isomorphism subspaces of R3. So, 4 subspaces. Cool. And now I think we're done for today. Thank you, everybody. Holy crap, I really appreciate your attention. Thank you for hanging out with me while I practice until I get a job, until I start making money again. John is the new Ramanujan. Not at all. Not even close. I'm like the opposite, dude. Ramanujan was just dreaming, literally dreaming about new, unproven, unsolved math. He was coming up with new math in his dreams, bro. I have never come up with a new original thought in math. I've come up with like new original thoughts about presentation of math, maybe teaching, but I'm not interested in making new math. I'm just not. I tried to, and I wasn't very good at it, and there's just a story there. I'm just not interested in research math. I think ChatGPT is going to be better than us at research math very soon. Like, dude, I'm not interested in pursuing something that AI is about to be better than me at. I want to be better than AI. I want to stay ahead of the curve on AI. I think that I'll be a better teacher than AI for a while. I don't think that's obvious. Not everybody's going to be a better teacher than AI, but I think I can be a better teacher than AI for a little while. Well, how are you going to be better than AI anywhere, really? That's a good question. That's a good, deep question to answer. I think things where they require humanity, like, that's almost by definition, because AI is not human. So something that benefits from it being from a human is, where humans can remain better than AI. Something that's just purely about knowledge and information is not. Like, AI is going to be better at that. But being a teacher is not just about the information, like the content of the words that I say, or even the video that I'm showing. Part of teaching is being like a motivational coach and motivating the student to want to learn math in the first place. And I think that I can be better than AI at that for a while, right? Like, I think teaching is something that, not for everybody, because one-on-one tutoring or even classroom teaching is expensive. Like, for most people around the world, like, dude, AI freaking as a tutor, as a one-on-one tutor, is an amazing thing, and it's going to improve education for most people around the world. But for a certain category of people out there who can afford to pay for a human teacher, a human teacher is always going to be preferable. Like an expert, really good human teacher, people are always going to pay for that if they can afford it. Like, the best teachers will be better than AI. An average teacher, I don't know. I'm not qualified to say. AI might be better than an average teacher in the future. I don't think it's there yet, but someday I believe it. But I don't think AI will ever be better than the best teachers. And if it is, then everything is broken. Everything is broken, and then we're just going to be cats. We're literally just going to be cats, just like licking each other and knocking shit off of tables just for fun. You know, just solving math problems just because it's fun and Sudoku. Like, if AI is better than a good teacher, then everything is broken. And I don't know. Nobody knows what should you do with your time on this earth if AI is better than a good teacher. You pursue a postgrad, you might as well teach people. I mean, I've considered this a lot. I started grad school applications. I was too late to apply for the fall cohort at my local university. I mean, I considered it. Grad school's not a bad option because I could get some teaching experience. Like, really, you know, I can be in charge of a classroom and I can get some classroom experience. But my goal is actually just to teach high school math. Like, I like high school math a lot. As much as I enjoy doing college level math, like linear algebra, like, I don't know. I can teach linear algebra to a good middle schooler. I did a couple days ago. I taught a middle schooler matrices and connecting matrices to the Fibonacci numbers. And I started hinting toward solving systems of equations and stuff like that. Like, I think that math education can really be reshaped into something that's more holistic. Like, not so much like level by level by level, but holistic, connecting all the different fields of math. And that requires somebody who knows many different fields of math, who has training in pure math and graduate level training in order to make those connections. I'm sure AI can't be as good as postdoctoral researchers. Is it not an algorithm? At best, it can gather existing information, but not have original thoughts. Disagree. I think it can have original thoughts pretty soon, if not already today. It's just very, very close. It's just combining with advancements in lean and formalization, soon you can just randomize. You just purely randomize and find someday the Riemann hypothesis. I believe that the Riemann hypothesis will be solved aided by AI. AI will help solve the Riemann hypothesis, like, with a math researcher. I believe that one will be solved with a math researcher using AI to solve it. I think that there will be other types of math that's not as, fashionable, not as much of a hot topic that everybody wants to solve. There will be like smaller results in math that AI solves 100% on its own, autonomously. I believe that, yeah. Can AI solve world hunger? I don't know. Nobody knows. It might create world hunger, is the thing. It's crazy. Like, it might create world hunger. It might solve world hunger. Like, we don't know. Nobody knows what's happening around the corner. Self-study students are already resorting to AI. It's phenomenal, yes, as a self-study person. if you don't have exams, deadlines, and other things, and if you're just really motivated, you can use AI in great ways as a personal tutor. It's really powerful. I love this math. Hell yeah. Me too. I love math too. Hit the subscribe button, everybody. Hit the like and subscribe. It's been a pleasure. I've been going for like 2 hours or more, so we gotta wrap this up. Yeah, 2.5 hours today. Let's go, dude. This is so nerdy, bro. John practices ASMR now. Yeah, I mean, exactly. I'm gonna go practice classical guitar, and we're gonna go watch some clips from Hawaii. So if you want to join me for that, it's always, I mean, it's a pleasure for me to hang out with you all while I practice, whether it's math or classical guitar. I mean, classical guitar is another thing that AI is not going to be very good at for a long time. It doesn't make money. Pure math doesn't make money. Like, I mean, yeah, AI might be good at it, but it's pure math doesn't make money. Like, we're going to be putting all of our money into getting AI to be good at coding. Like, to be good at coding, people can save money or build better AI, etc. And in the process of us trying to replace software engineering, we are also training AI to be good at math, because math is similar to software. It's a purely logical field, like building abstractions and building logical statements from nothingness. Like, software engineering is so similar to math in this, like, things are either correct or wrong. And by training AI to be good at software, we're also training AI to be good at math. And dude, I want to play with that. I want to play with those tools. I want to solve the Riemann hypothesis. Just joking. But, like, if I could contribute somehow to AI math, like, that'd be super cool. So is coding obsolete? Yeah. I think so. Just an AI thing. Yeah. I mean, not yet, but within 5 years, I think we'll be coding stuff by hand for fun, because it's beautiful, because it's fun. It's still fun, and it exercises your brain to write things by hand in Vim, because it's just beautiful. AI can create music. It can create slop music. Yes, AI is good at making slop music, at music slop, but most people don't know it's slop because they don't have refined taste in music, and it's good enough for most people. Yeah, AI is good at music for sure, dude. But it's not going to be good at, like, classical music performance. It's going to be good at making derivative, generic pop music. It already is very good at that. It's very good at making generic pop music. But it's not going to replace somebody performing Bach. It's not, like, why, like, nobody's going to give a standing ovation and clap for robots performing Johann Sebastian Bach. And there are people who are being paid to play Bach. Like, so I don't know. That's something that I think AI can't touch. Really, kind of generally, athletics. Anything that's athletic, that is impressive because it's a human who has spent hundreds, thousands of hours easily training to be perfect at a bow and arrow, or, freaking lifting weights or something. Like, anything athletic. And something like classical guitar is athletic. It's athleticism. I'm working out every single day. It's just athleticism of small muscles. It's like, yeah. It's I don't know. It's an athletic thing, and people don't realize. Let's see. Is K Theory live? I want to see. Is K live? If so, I want to go say hi. And if not, I want to go practice classical guitar. K is not live. I don't see anybody I know who is live. Do any of you all have any holoscience? I talked about this a lot earlier today. So if you want to rewind the video, holoscience, I don't want to go through it all over again, but Cosmic 4 asked this: how to study calculus more efficiently, and I talked about deliberate practice. I talked about spaced repetition. I talked about my method working through multiple different subjects and using spaced repetition. And then I think I went up here and I talked about Arian asked about how much math to study per day, and I said every single day. That's the important part. Get into the habit of studying math every day. I talked about, this is the part that I really wanted to get at. Most people think of solving all 100 exercises in a book in section 1 before you go to section 2. That's a dumb idea. Don't do that. Do a few problems from section 1, then a few problems from section 2, and then I think go back to section 1, do another problem, go to section 2, do another problem, and then add section 3 and do a problem. Then come back, do a little bit of 1, a little bit of 2, a little bit of 3, a little bit of 4, come back, do a little bit of 1, 2, 3, 4, 5. So this is called breadth first search. Lockheed. Yeah, we missed you, dude, with all your like crazy graduate level, topics. Yeah, we stayed a little more down to earth today with my rants today. So if you want to watch this, I talked a lot earlier. Somebody else asked holoscience. So you can rewind and you can watch me talk about this earlier. But yeah, it's really, to me, the key is deliberate practice. Like, try to understand and study the science of habit building and deliberate practice, craftsmanship. That's how you get good at anything, I think. Thanks for watching. Bye. I'm going to go practice classical guitar now. It's similar to this stream. It's just guitar instead of math. So thanks for watching. Bye. See you soon. See you on the other side, y'all. Let me see. I need to make sure I'm logged in correctly to this other account. Something went wrong. All right. Hope to see you in the other channel. Oh, you know what I'm going to do? For anybody who's live, let me warm up right now. Let me play the song, dude. Okay, let me play you all a song. If this sounds interesting, if you want to see more of it, you can join me in the guitar stream. I kind of always like to play a little bit of Bach, because, Bach is so mathematical and beautiful. So here's a familiar one that you probably know, or you might recognize. It's called The Prelude from the First Cello Suite by Johann Sebastian Bach. And y'all, I hope you enjoy it. There's no background music in this scene. Good. Okay. Ooh, sorry. My bad. I wasn't showing the iPad during when I was talking about, I was showing all the deliberate practice and other things. My bad. Oh, well, whatever. Sorry about that. yeah, dude. Heck yeah. Thank you for watching. If you want to see more classical guitar, you can join me in the guitar channel. Otherwise, yeah, I really appreciate you all. A couple ways, if anybody wants to extend some gratitude and, help me, try to turn this into a sustainable thing, like a sustainable stream. Because, as much as I do want to teach in a high school, like, I'd love to teach at a middle school or a high school. It'd be quite a dream if I could, freaking do this full time. I've got to buy me a coffee. You could, one-time tips or recurring tips if anybody wants to become like a channel member before I even have channel memberships. There is buy me a coffee. But also subscribe to my guitar channel. That can help. Or another one that I always like to mention, completely freaking free and is, super easy to do. Leave a comment. Right? I don't mean in chat, like right now, but once the video is over, you could leave a comment in the public, final, public comment section of the video and just say, thanks, dude, this was awesome, or something like that. That goes a long way, because when people click the VOD, they don't see all the chat. They just spend 5 seconds deciding if they want to watch the video or not, and seeing comments of people who say, thanks, dude, this was awesome, or something. It goes a long way. So that's a totally free way to help me on my journey, as an artist and as a teacher. So those are some options. I'm not monetized yet, but you could tip or super chat in the JC practice in my first channel. So thanks for watching. All right, that's about it. Let me set up the redirect and everything. Hell yeah, guitar on the math stream. Oh yeah, dude. And also, I meant to say, math on the guitar stream, y'all. If you want to keep talking about math and just ask some questions and talk about math, literally just come join us in the guitar stream, and I'm down to just keep talking about math, dude. There's no law that says that I can only talk about math in the math stream and can only talk about guitar in the guitar stream. So it's just, yeah. I want to be blending the two a bit better, because we're all multi-dimensional people, right? Okay, see you all in the guitar channel. Thanks for watching. Bye, bye, bye.